Hello and welcome back to Reinforced Concrete Design. In this lecture, we're going to continue with detailing, specifically looking at bar scheduling. Arrangement of reinforcement can be very complex. As you can see here, there are many different shapes of reinforcing bars that can be required in just one concrete member. Here you can see different shapes of reinforcement used in steelwork. The location, mark, type, size, length and number, and bending details of each bar or fabric in a reinforcement drawing of a structure is described in a comprehensive list. This process of listing the location, type and size, number of, and all other details is called scheduling. In the context of reinforcing bars, it's called bar scheduling. In short, the bar bending schedule is a way of organizing rebars for each structural unit, giving detailed reinforcement requirements. The design of the reinforcement for a concrete member will generally lead to a requirement for a variety of shapes as well as straight bars. These will be shown on the reinforcement drawings. The information on the drawings is transferred to a bar schedule that gives the number of bars the required shape in accordance with BS 8666, Scheduling, Dimensioning, Bending and Cutting of Steel Reinforcement for Concrete. Let's look at some tables of standard shapes as defined by BS 8666. These tables include parameters defining the geometry of the shapes. As you can see, the shapes vary in geometrical complexity and can include several bends. The shapes can be open or closed, and each shape has a reference number called mark. Most of the shapes included in these tables are planar. However, they can also be three-dimensional. For example, the shapes 77 and 98, as shown on this slide, are three-dimensional. Here you can see a bar bending schedule describing shapes that are required for the construction of a slab. The table provides necessary numbers, values of geometrical parameters, and the weight for each bar in the steelwork. This schedule is sent to the supplier of the reinforcement so that they can cut and bend the bars. The shapes from the bar bending schedule are shown on the reinforcement drawings. Here you can see detailing of reinforcement in the slab. The drawing shows marks, numbers, locations, and spacing for each bar shape. The drawings should detail reinforcement around special geometrical features of the structure. For example, here you can see the arrangement of reinforcement around a hole in the slab. This is a bar bending schedule describing necessary numbers, values of geometrical parameters, and the weight for each bar in the steelwork of a beam. This slide shows examples of reinforcement arrangement in concrete beams. As can be seen, mark, location, and number are specified for each bar. The information on reinforcement arrangement in beam cross-sections is provided using sectional cuts. Let's consider three sections of the beams shown. Here you can see the arrangement of reinforcement in section 1.1 and in section 2.2 of beam A and in section 3.3 of beam B. This is a plan view detailing reinforcement in the beams between four columns. The plan view does not provide information of the changes of elevation in the slab. This information is included in the sections together with detailing of reinforcement. Section 1.1 shows the arrangement of reinforcement in the left beam and changes in elevation between two adjacent spans. Section 2.2 provides similar information for the bottom beam. Section 3.3 for the right beam, and Section 6.6 for the top beam. This is a bar bending schedule describing the necessary numbers, values of geometrical parameters, and weight for each bar in the steelwork of columns. The reinforcement is detailed along the entire columns. Here you can see the arrangement of reinforcing bars in the column at the ground floor. A rectangular cross-section of the column and the arrangement of longitudinal bars and links is shown in section 3.3. Here you can see the arrangement of reinforcing bars in the column at the first floor. And here the arrangement of reinforcing bars in the column at the top floor with corresponding cross-sections.
The continuity of longitudinal reinforcement between floors is assured by laps and cranks. The columns are anchored into pad foundations with reinforcing bars. The sectional cuts show that some columns have square cross-sections, while others have rectangular cross-sections with more complex arrangement of links.
And that concludes the topic of detailing in reinforced concrete design according to the Eurocode. I really hope you found it helpful.